Okay, now that we have done the formation of vector 1 that represents the depolarization vector of the middle side of the left ventricular septum, now it's time to study how the vector 2 is formed. Now, first of all, what is vector 2 representing? It's going to represent the major part of the ventricles, okay, and it also represents the leftover of the septum. So if you see, this is a time when the rest of the part of the ventricular septum will be depolarized, okay. Since the direction of the vectors is being neutralized, therefore no net vector of the septum is generated during this time, okay. Similarly, if we talk about the free walls of the right ventricle and the left ventricle, the majority of the vectors are neutralized because of the opposite direction of each other. But because the left ventricle is thicker than that of the right ventricle, there is some remaining portion of the left ventricle which is able to generate a net vector. Okay, so the left ventricle contributes to that. There is another part of the heart that contributes to the vector 2, and that is the apex. So the vectors generated by the apex are not neutralized by anything because you have your mitral valve and the tricuspid valve opposite to the apex, and they are not generating any kind of vector. Hence, apex plays an important role in generating the net vector. So the left ventricle and the apex, these are the two things that will form the net vector 2. Now it's very important to know the direction of the vector 2. Now it's very important that you commit this to your memory, that what are the different directions of the atrial depolarization vector, the vector 1, 2, 3 of the ventricular depolarization, and the repolarization. Secondly, you need to know the positioning of the leads, and thirdly, you need to know the concept of the deflection of the current when it hits the electrode. Once you know these three things, you will actually be able to make out and start to interpret the ECGs. Okay, so the direction of the vector 2 is towards the left. Okay, then it's posteriorly, and it could be superior or inferior. Okay, so I'm kind of like talking about in a three-dimensional plane. This is the direction of the vector 2. Now, if we try to kind of like dissect the vector in horizontal plane and the frontal plane, you will see that this is the direction of the vector 2 here, and it will have a positive deflection in the leads V5 and V6 because now the positive side of the vector is facing the recording electrodes, which in this case are V5 and V6, hence we have a positive deflection. But the negative side is facing the recording electrode here, which is the V1, hence we have a negative deflection. The concept is same everywhere, okay? When the positive side of the vector faces a recording electrode, you will have a positive deflection, and if a recording electrode is facing the negative side of the vector, then you will have a negative deflection. So now coming to the frontal plane. Now if we consider this as vector 2, we know this is the positive side and this is the negative side. If you try to record the deflection in the lead 1, we will have a positive deflection, and if you try to record it in lead 3, we will again have a positive deflection. Okay, because now these recording electrodes are facing the positive side of the vector. Okay, the vector is this way, the vector is this way. Okay, hence you will have positive deflection. So this was about vector 2, or the depolarization of the free walls or both the ventricles.